Morning. We will continue with our lesson indices. We have already completed two parts of indices and we will be going to the third part today. Before we begin today, let's just recall what we learned in our lower classes as well as in the first two lessons of indices. Now, in lower classes, you must have seen when you were multiplying. Let us say, for example, 2 into 3, you were getting the answer 6. And the same if you did by writing 3 first and 2 again next, again you get the same answer 6. What we come to know from here is that whichever number you write first in multiplication doesn't matter, you will get the same answer. So, this is one of the principles that we will be using today in our indices lesson. And from indices lesson, what did we learn in last class? Let us say if we have a number and we have a rational number as an indices, what does it mean? It is the square root of 25. That means this denominator is denoting the root. And we were always having 1 as a numerator. But now today we will see a rational number in the form of m is to n. For example, 2 is to 3, 4 is to 5, and so on. That means the numerator also will not have 1 but some other number. Then what does it mean? That is what we will be doing today, right? So I hope you have recollected this principle. That is, when a rational number is present above a number as an indices, the denominator represents the root. For example, let us say again 64 raised to 1 upon 4. This was fourth root of 64, which was written as like this. So I hope you have done the assignment and gone through the earlier video. Then only you will be able to understand this video. Or stop this video, go to the earlier video, again understand the concept of this rational number as roots, and then again proceed to watch today's video. So let's begin. Now earlier we have also even learned in laws of indices that a raised to m multiplied by n is nothing but a raised to mn. Now here you can see this is multiplication. So it doesn't matter whether m comes first or n comes first, right? So a raised to m into n will also be equal to a raised to n into m, because multiplication, the number of the position changes, doesn't make any change in the product. So let us say, for example, let us prove whether what we are saying here is correct or wrong. So let's take an example. I have 8 raised to 2 upon 3. Now this 2 upon 3 can be written in two different ways. It can be written as 2 into 1 upon 3 or 1 upon 3 into 2. Now you can see either 2 can be written first or it can be written later on. Then what difference does it make in the indices? So 8 raised to 2 upon 3 can be written as 8 raised to 2 in the bracket, 1 upon 3 outside. So you see 2 into 1 upon 3 is 2 upon 3. Or 1 upon 3 can be written first and 2 outside. Again you can see 1 upon 3 into 2 is again giving you 2 upon 3. So these are the two different methods. Now let us see whether they give us the same result on solving. Then only we can say that these two will be equal. So let's solve this first. 8 square means nothing but 8 into 8. 8 into 8 is 64. 64 raised to 1 upon 3. What does this mean? Cube root of 64. And what does cube root of 64 mean? That we should divide 64 into 3 parts and take 1 part out of it. So what are the 3 parts of 64? 4 into 4 into 4. 4 4s are 16, 16 4s are 64. And we remove it one time outside like how we did in our last class. So you can see the answer that I am getting is 4. Right? Did you understand? Let's repeat what we did. 8 square. That means 8 into 8. 8 into 8 is 64. I have solved the bracket. Now 64 raised to 1 upon 3 means what? Cube root of 64. And how do you find cube root of 64? Divide the 64 into 3 equal parts. That is 4 into 4 into 4. And we take it out once because you can see 1 out of 3. 1 part out of 3. So 1 part out of 3 is 4. So when we solve it this way, we are getting the answer 4. Now let us see the next part. Now next part, what it says inside the bracket is cube root of 8. Cube root of 8 is inside the bracket, 2 is outside. How do we find out cube root of 8 again? We divide 8 into 3 parts. So 2 into 2 into 2. And we take it out only once. One part out of 3. You can see one part out of 3. So we have 3 parts. We remove 1. So this becomes the cube root of 8. Cube root of 8 is 2. And then we have a power of 2. 2 raised to 2 means 2 into 2. The answer that we get is 4. So you can see we are getting the same answer whether we do the square first or whether we do the cube root first. So this 8 raised to 2 upon 3 can be written in both the methods and both the methods are correct. Only the way we read this will be different. Reading is always done from outside to inside. This reading will be cube root of square of 8. This will be read as square of cube root of 8. Whenever you have to read or write it, it will always be from outside to inside. Right? Let's take one more example. 16 raised to 2 upon 4. Now you can see 16 2 upon 4. This also I can write it in two different forms now. 16 2 I can keep it inside. 1 upon 4 I can take it outside. Or I keep 1 upon 4 inside and 2 outside. So you can see 2 into 1 upon 4 is again 2 upon 4. So let's solve this also and see. 16 square, that is 16 into 16, which is 256 raised to 1 upon 4. Now what does this mean? Fourth root of 256. So that means I have to divide 256 into 4 parts. So we have 4 into 4, 16. 16 fours are 64, 64 fours are 256. So can you see again I divided 256 into 4 parts and I have to remove only one part out of 4. So out of the 4 parts I again remove one common and I get my answer 4. Now let's do this first now. In this again what does this mean? Fourth root of 16. Right? 16 raised to 1 upon 4 means fourth root of 16. So again now I have to divide 16 into 4 parts. So 2 2s are 4, 4 2s are 8, 8 2s are 16. So you can see I have divided 16 into 4 parts. And then what we do? Remove one part out of it. Out of the 4 parts of 2, 1. Excuse me. So 2 is the fourth root of 16 raised to 2. So 2 raised to 2 means nothing but 2 into 2. So the answer that we get again is 4. So as you can see, we are getting the same answer 4. Whether we square it first or whether we remove the root first. It doesn't matter because we are completing both the functions one after the other. Whichever function we do first will not affect the final answer. Again, as I said, reading would be from outside to inside. We start from the outermost. How do we read this? Fourth root of square of 16. So now from here you can see the denominator is denoting root. The numerator denotes the power because you are squaring it. It's the power, right? And the root is the denominator. So the two numbers of a rational number denotes two different things. The numerator denotes the power and the denominator denotes the root. Okay. So how do we read it? Fourth root of square of 16. Same thing here. Square of fourth root of 16. So these are the two ways in which one number, a rational number which is present as indices, can be expressed. And on solving, you will get the same answer. So just let's very quickly take some examples. For example, I have 15 raised to 2 upon 3. Now you know I can write it in two different forms. 15 square 1 upon 3. Or I can write it as 15 1 upon 3 2. So how do I write this? I write this as cube root of square of 15. And this I will write as square of. Why am I writing square of? Because that is outside. I start from here, then I go here, and then I go here. So square of this number then. Cube root of 15. Right? Here also we started with the first outside cube root. Then we went to this square and then we went to the number. So 1, 2, 3. 1, 2, 3. This is the order in which you will be writing it. So let's take another example. Let us say 18, 2 upon 7. How can we express it in two forms? 18, 2 inside, 1 upon 7 outside. 18, 1 upon 7 inside, 2 outside. So this will be written as seventh root. Right? This is in the denominator, so it is the root. This is the numerator, so it is the power. Seventh root of square of 18. Similarly, this will be written as square of, right? We are starting from outside. Square done. Now this. Seventh root of. And in the last, the number 18. So I hope you have understood. Any number, if it has a rational number in the form m is to n as indices, it can be written as the power inside and the root outside, or the root inside and the power outside. It will not make a difference, because on multiplying it will always give you m upon n. Thank you.